Hello and welcome to The Space Above Us, Episode 38, Apollo 11 Part 2, Tranquility Base. Last time, we rode along for the thrilling powered descent of Apollo 11. Communications issues, a downrange landing, and baffling computer problems all tried to throw a wrench in the works, but on July 20th, 1969, the lunar module Eagle gently settled down in the Sea of Tranquility. We also kept up the suspense and ended the episode immediately after Armstrong's famous radio call, "Houston, Tranquility Base here, the Eagle has landed." If you've ever wondered why Capcom Charlie Duke stumbled in his response, "Roger Twant, Tranquility, we copy you on the ground," it's because he'd never heard the term Tranquility Base before. No one had. Armstrong just made it up. And if you haven't heard that audio before, fear not. I'll include the entire powered descent audio in an upcoming supplemental before the next episode comes out. But as exciting as the landing was, there was still a lot more to the mission. When we left Neil Armstrong and Buzz Aldrin, they had just touched down and shut off the engine in the newly dubbed Tranquility Base. What followed was actually anything but tranquil. There were two predefined points shortly after landing where the crew and mission controllers would decide if it was safe to stay. Any number of things could impact this decision. Maybe the LEM was leaking air, or maybe the engine was leaking fuel. Maybe the batteries are failing, or maybe the LEM was slowly sliding down a hill. For this decision, Mission Control switched from a go, no-go pole to a stay, no-stay pole to avoid confusion. Did go mean leave or stay? Better to just change the phrasing. There were lots of reasons to leave right away, and only a few minutes to re-rendezvous with the command module before they'd have to wait 2 hours for Columbia to circle around again. So the crew had to get to work on the launch countdown right away, just in case they had to leave right away. This brings us to a point that I actually hadn't really considered before researching this podcast. When a rocket takes off from the Earth, it requires dedicated infrastructure, thousands of specialized technicians, and weeks of planning. When Eagle took off from the surface of the moon, it would have 2 guys and no external resources. A ton of effort went into making the lunar ascent phase of the mission as simple as possible, but that still left it pretty complicated. So the first task for the lunar visitors was to assess the state of the spacecraft and then immediately start preparing to leave. Thankfully for all involved, everything looked fine. Landing on the moon and returning home without going outside would have technically fulfilled the original challenge, which, said nothing about actually getting out, but that would have been pretty lame. In fact, the guys were so antsy to get started that Mission Control had to accommodate a little massaging of the schedule. The original timeline had Neil and Buzz taking a nap shortly after landing in order to rest up for the extravehicular activity to come. I don't know what the person who planned this schedule was thinking, since who could possibly go to sleep after such an exciting event? I guess the idea was that both astronauts had just been through an incredibly stressful 9 or 10 hours and could use a rest before a groundbreaking EVA planned to last over 2 hours. But come on, who could see that view out the window and resist? The crew asked to perform the EVA first and rest later, and the ground agreed. At 9:39 p.m. Eastern Time, the spacecraft had been depressurized and the commander opened the hatch. But wait, we're skipping a step here. When the crew left the safety of the lunar module, they would also leave behind its environmental control system. And astronauts are big fans of oxygen. So, what to do? What they did was put on their spiffy A7L spacesuit, also known as an extravehicular mobility unit. Over the course of this show, we've at least touched on a number of different spacesuits used throughout the space program. There was the silvery suit used on Project Mercury, the converted high-altitude suit used on the X-15, the G3C and G4 suits used by most of Project Gemini, and the lighter G5C used on the long-duration Gemini 7 mission. We also touched on the new fireproof design of the suits introduced after the Apollo 1 fire. All of these spacesuits had the same basic task: keep the crew safe in the event of an unexpected cabin depressurization, and in the case of EVA, keep the occupant safe while he scooted around outside the spacecraft. What they also had in common was that they were all tethered to the spacecraft with a bunch of hoses and electrical cables. For a moonwalk, this would be no good. Instead, the astronauts would strap on a large backpack known as the Portable Life Support System, or PLIS. This would essentially make the astronaut into their own little spacecraft, independent and self-contained. The Bliss had a few things to do. First, and most obvious, they had to provide oxygen for the astronaut. No oxygen, no astronaut. It also had to filter the in-suit atmosphere, removing carbon dioxide, an excess of which would also soon lead to no astronaut. Less critically, though still important, it maintained a comfortable temperature and humidity and removed any cruft that managed to get into the air system. If this all sounds familiar, it's because it sounds a lot like the environmental control systems of all the spacecraft we've talked about. We've come a long way from the complex, heavy, and finicky systems of Project Mercury. In addition to the environmental control system, the suit also had to provide a communication system. Comms didn't have to go far, though. Voice and biomed telemetry were relayed through an antenna on the top of the suit back to the LEM, and from there to Houston. Though the antenna proved a tight fit inside the LEM, scraping along the ceiling. The backpack sort of looks like it's just one big item, but on top is actually a totally separate component, the oxygen purge system. This was an emergency backup supply of oxygen that would allow the astronaut about a half an hour to scamper back to the LEM in case the Bliss failed. The whole thing weighed about 120 pounds on Earth, but only about 20 pounds on the Moon. Low gravity does have its advantages. What's kind of crazy is that the Bliss was tested only once in space, back on Apollo 9. And even then, it was not for that long. I guess they were confident in the results. I don't think I'm spoiling anything here by telling you that in a few minutes, we'll learn that Neil Armstrong was the first human to set foot on the Moon. But what you might not know is that it wasn't always necessarily the case. The decision of who would set foot on the Moon first is a complicated one. As I mentioned before, it easily could have fallen onto the crews of Apollo 10 or 12 in addition to 11. So all of the crews were chosen with that in mind. But on top of that, the crews shifted a fair amount. The original LMP for Apollo 11 was Fred Hayes, who got bumped when Buzz Aldrin was moved out of the CMP role to accommodate a shift by Mike Collins. These decisions ultimately determined which two men would descend to the surface, but what about who would get out first? Actually, the original question may have been who would get out at all. And that's because for the early missions at least, there was a thought that perhaps only the lunar module pilot would crawl down the ladder. That would make Buzz Aldrin the first man to walk on the Moon, and leave Neil Armstrong off of it entirely. This seems pretty insane at first, but think about it. Who did the EVAs in Project Gemini? The pilot did. The command pilot stayed on board and kept an eye on the spacecraft. Who went outside on Apollo 9? The LMP and CMP did. Commander Jim McDivitt stayed inside. It also made sense to have someone in the LEM keeping an eye on things. The LEM had barely any flight history and would have just been plopped on the surface, likely with substantial force. Who would make sure that their ride home was okay? Leaving the commander inside wasn't the worst idea. As the landing grew closer, the plan returned to having both guys getting out. Mission Control was confident in their ability to keep a close eye on the LEM, and while it wasn't a top priority, there was some concern about what it might do to an astronaut's mental state to send them home one ladder away from the Moon. Perhaps most importantly, in simulation runs of surface operations, it became clear that it was a two-person job. So what gave Armstrong the final edge? I've heard a couple different things. One story says that Armstrong pulled rank. He was the commander, he was going first. Another story was that rank was pulled for him by the mission planners. Something along the lines of, Neil's the commander, he's going first, sorry Buzz. There's also my favorite, that the way the hatch opened made it physically easier for the commander to get out first and come back in last. Part of me suspects that the hatch thing was just a minor, if valid, technical reason that was glommed onto as an objective way out of a subjective mess. But who knows? Let's get back to where we were. 9:39 p.m., July 20th, 1969. Eagle's hatch was open. Armstrong got down on his hands and knees and slowly backed onto the front porch of the LEM. With his bulky backpack, this wasn't a trivial task, but Aldrin gave him some direction to make it a little easier. He carefully backed up to the ladder and began the final descent. On the way down, he pulled a lanyard to deploy and activate a slow-scan television camera. A TV audience of unprecedented size would join Armstrong for the first step. By the way, if you'd like to learn more about how that TV signal was captured on Earth, check out the movie The Dish. It's both informative and really funny. On reaching the bottom, he discovered that the last rung was higher than expected. In a way, this was actually Armstrong's fault, since he had landed Eagle gently enough to not use much of the shock-absorbing crush core in the LEM leg, resulting in a slightly higher ladder. In 1/6 gravity, it posed no major problem, however. Armstrong demonstrated that fact by leaping from the LEM footpad up to the bottom rung. I've always wondered what the plan would be if he couldn't make the jump, but I never ran that one down. Standing on the LEM footpad, Armstrong surveyed his surroundings, describing the surface and the state of the LEM. He relayed, "I'm at the foot of the ladder. The LEM footpads are only depressed in the surface about 1 or 2 inches, although the surface appears to be very, very fine-grained as you get close to it. It's almost like a powder. Down there, it's very fine." He paused for a moment, and then said, "I'm going to step off the LEM now." Armstrong picked up his left foot and set it down on the surface of the moon. He uttered a sentence that will likely live on as long as human civilization. That's one small step for a man, one giant leap for mankind. Before we move on to surface operations, I want to take a moment to address the man versus a man thing. The truth is that nobody, not even Armstrong, is totally sure if he said one small step for a man or one small step for man. He had planned to say a man. Audio analysis had indicated he may have said it, and the quote makes sense with it. But it was also a pretty exciting moment, and he may have just flubbed the line. It's also possible that the radio didn't quite pick it up. When you say for a quickly, the 2 syllables can kind of slur together and sound like one. For a man. Especially over a scratchy radio link from 250,000 miles away. Personally, since a man is clearly what was intended, and it is plausible that he did say it, that's what I'll go with. With history made and ambiguous quotes uttered, it was time to get to work. There was a very limited amount of time available to accomplish a lot of tasks. First on the agenda was the contingency sample. The idea here was that the first thing Neil would do is grab a nice-looking rock and put it in a pocket on the leg of his suit. That way, if something went wrong in the EVA and they were forced to leave early, they'd at least have something. As Armstrong busied himself collecting the sample and taking photos of the landing site, Aldrin prepared to come down next. Armstrong did what he could to guide him from the surface, and a little over 20 minutes after Armstrong's first step, Aldrin was on the surface. He commented, "Magnificent sight out here. Magnificent desolation." The 2 astronauts wasted no time, starting the process of deploying experiments and instruments as soon as possible. While they were doing so, they performed little experiments and observations of their own. A lot of stuff doesn't work the way you might expect on the moon, even if anyone who thought it through could have predicted it. For example, as Armstrong recounted later, footsteps don't kick up dust. The reason you kick up dust on Earth is you're disturbing the air near the dirt, or forcing air out of it by stepping on it. Once kicked up, the dust gets forced in all sorts of directions by the turbulence and eddies of the atmosphere. On the moon, the dust simply gets compressed down. If you were to kick some, the particles would just fly off in a sheet and land nearby after following short little suborbital trajectories. Weird. They also experimented with different methods of walking around. Between the low gravity and the heavy backpacks throwing off their center of mass, walking could be a little tricky. They tried skipping, kangaroo jumps, and normal walking. Most of the astronauts eventually settled on a sort of low-gravity loping motion. Step, step, float. Step, step, float. Step, step, float. But that had its own issues. With so much momentum, astronauts had to think a few steps ahead and be careful with sudden stops or turns. Several experiments were deployed on the surface, with some remaining and some coming home. An example of an experiment that came home was a deployable reel of foil that was designed to capture solar wind particles, taking advantage of the hard vacuum of the lunar surface. An experiment that remained there was a special type of mirror called a retroreflector. This mirror would reflect light back in the same direction it came from, allowing scientists on Earth to bounce a laser off the surface of the moon and precisely determine the distance between the two. The retroreflector required no power to operate, and lasers were regularly bounced off of it for decades. Take that, moon hoaxers. There was also a fair amount of time given to ceremonial or symbolic acts, which is to be expected on a mission like this. Armstrong and Aldrin unveiled a plaque on Eagle's leg that read, "Here, men from the planet Earth first set foot upon the moon. July 1969 AD. We came in peace for all mankind." I really love that plaque, because it easily could have been something in the spirit of, "America rules, Soviets drool," but no, it celebrated the accomplishment as something for all of humanity to be proud of. But they did deploy an American flag, which remains there to this day. You might think that this would be some kind of special flag made out of space-age superpolymers or something, but no, it was bought off the shelf for about $6. The crew also took several minutes to exchange words with President Nixon, in what Nixon remarked must be the most historic phone call ever made. Among other things, Nixon said, "For one priceless moment in the whole history of man, all the people on this earth are truly one." It felt like the EVA had hardly begun when Houston warned Buzz that he only had about 10 minutes left before it was time to get back inside. Buzz came in first, followed a few minutes later by Neil. Neil got a little overzealous on the jump up the ladder, landing on the third rung after jumping about 6 feet. Quite a vertical leap. 2 hours and 31 minutes after it began, humanity's first EVA on the surface of another world was over. The crew repressurized the LEM, removed their bulky backpacks, and finally took that rest period that was originally scheduled for right after the landing. Aldrin slept on the floor by the hatch, while Armstrong slept on top of the ascent engine with his legs supported by a sling above Aldrin. Both men kept their suits on in case of an unexpected depressurization. It also helped damp out some of the sound from the noisy life support equipment in the LEM, but neither slept all that well. Those bulky suits also led to one of those spaceflight moments that just makes you shake your head. At some point while moving around with the cumbersome suits inside the LEM, Armstrong broke off part of a circuit breaker that was required in order for the ascent engine to operate. The solution? Jamming a felt tip pen in there. That's how they came home. I love the space program. After about 22 hours on the surface, the crew performed the traditional countdown, and Eagle's ascent engine rocketed off into the black sky. Aldrin noted that the blast from the engine knocked over the American flag in the process. Whoopsies. Ascent was smooth, with the engine that had caused so much trouble during testing flying like a dream. I'm going to fast forward a little bit here and tell you that rendezvous, trans-Earth injection, and re-entry all happened with no issues. Although right before docking, Collins asked Armstrong to rotate the LEM so that he could inspect it, and Armstrong flew right into gimbal lock. Normally that would require realigning the entire guidance platform, but since they were just right there, Collins was able to snag them. On July 24th, the crew of Apollo 11 safely splashed down in the Pacific Ocean and promptly tumbled over into the apex down position. Once again, returning space-age heroes were left to hang helpless in their couch straps until the airbags deployed and righted the vehicle. And here's where things started to get a little weird. Everyone knows that the moon is a lifeless chunk of rock. We know that now, but in the 60s we weren't totally sure. The chances of some kind of moon germ coming back and causing a global pandemic were vanishingly small, but the consequences of that happening were enormous. So someone somewhere figured it was best to play it safe. With that in mind, the Apollo 11 astronauts returned not to ticker tape parades, though those would come later, but rather to a quarantine trailer. The trailer would be transported to the same facility in Houston that was receiving the moon rocks, and they were scheduled to remain in quarantine there for 3 weeks. It was a pretty spacious facility, and they had company in there, but it still must have been a bit of a bummer to come back to, even if the quarantine was ultimately cut short. That still left the question how to get them to the quarantine trailer. This is the best. The plan was that once recovery forces arrived at the command module, they wiped down the area around the hatch with disinfectant. Then they opened the door and real quick threw in some biological isolation suits and closed the door again. What would have happened if there were moon germs and they were airborne? Well, they weren't, so hooray! Inside, the crew would put on their suits and then climb out to the recovery raft. Then the recovery people would rub them down with more disinfectant, and the astronauts would return the favor. Once they got on the carrier, they were ushered right into the quarantine trailer. Once quarantine ended, the entire crew performed the traditional worldwide publicity tour, and none of their lives were ever the same again. But more than their lives, the world was never the same again. Not much had changed on Earth over the course of this mission, but somehow everything changed. Humans had walked on the moon. NASA had risen to Kennedy's challenge. We had proven that humans were capable of anything that we set our minds to. The Apollo program had confirmed that in concrete terms anyone could understand. Just look up. It's even part of the vernacular at this point. How many times have you heard, if we can land a man on the moon, why can't we? It's the classic touchstone for a seemingly impossible task conquered by human ingenuity. Those footprints in the dust represent the collective potential of an entire species. And, we're sort of drifting off of Apollo 11 at this point, but that is part of why I think a human spaceflight program is so important. With so many daunting challenges facing our planet, having a shining example that yes, we can do this, we've got this. That example can have such a beneficial effect on society as a whole. We can do it. Next time. Kennedy's challenge had been fulfilled, but the Apollo program still had a lot left to do. Join us in 2 weeks as we do it all over again with the crew of Apollo 12. Oh, and you may want to double check the location of the signal conditioning equipment switch. Might just come in handy. Ad Astra. Catch you on the next pass.